Chemistry of mole concept is very useful concept, especially to school level learners. This concept is very helpful while solving various numerical problems relating to microscopic particles. Besides explanation of related theoretical concepts, some numerical problems are solved step by step here in this video. The explanation is in very lucid manner to make you easy to understand. I hope and believe that you will enjoy your learning chemistry. Before starting, I request viewer to subscribe the channel. Let's proceed. The scientist Amedeo Avogadro was born in Italy 9th of August 1776. The most interesting thing is that he started his career as a lawyer and finally switched over to natural science. His famous hypothesis is Avogadro's law. Mole is an unit much used to express the numbers of microscopic particles. One unit is equal to Avogadro's number. Visible things are expressed in numbers like dozens, hundred, etc. This concept is very useful in explaining the amount of reactants and products in various chemical reactions. This is applied to all three physical states of substances, that is, solid, liquid, and gas. In continuation of explanation of mole, here different examples in all three physical states are shown for better understanding the concept. How the particles of gaseous substances are doubled or tripled while switched over to atoms from molecules are shown here with examples of hydrogen and ozone. Mass of an atom, while you consider, that means number of protons and number of neutrons present in the nucleus. Electron is not considered because of its negligible mass, such as in the case of lead, 82 protons and 125 neutrons, making a mass number 207. Now we proceed to the molar mass. Molar mass is the amount of substance that is present in 1 mole. Unit of expression, that is grams per mole. Example like FeSO4, its molar mass is 152. So mass of one atom, atomic mass, while expressed in gram, that is gram atomic mass. Mass of one molecule, that is molecular mass, expressed in gram, gram molecular mass. This is summary sheet on molar mass, that is atomic mass, molecular mass, formula mass, gram atomic mass, gram molecular mass. How to determine the number of moles in solid substances? Number of mole is equal to mass of the substance divided by the molar mass of the substance. Molar mass of the substance may be atom, molecule, formula mass, ions, radical, subatomic particles. Explanation. Determine the number of moles of 76 gram FeSO4. Molar mass is 152. So number of moles of FeSO4, 76 divided by 152, is 0.5 mole. Molar volume of gaseous substances. That is gaseous particles. If it is a 1 mole of gaseous molecules, Avogadro number of molecule occupying 22.4 liter at STP. Similarly, gaseous particles containing 1 mole of gaseous atoms occupying 22.4 liter containing the Avogadro number of atoms. For example, of molecule H2, that is 1 mole, if you add on energy, breaks into 2 atoms of hydrogen, that is 2 moles. So that is the volume increasing, number of moles also increasing. How to solve numerical problems relating to gaseous substances. N is equal to V by Vn. N stands for number of moles, V volume of gaseous particle at STP. Vn is the volume of Avogadro's number of gaseous particle at STP. If V is given at different temperature, then you have to convert to the STP using the combined gas law. P1 V1 by T1 is equal to P2 V2 by T2. Hence it is necessary to go through Charles' law, Boyle's law, Avogadro's law, combined gas law. Avogadro's law, B proportional to N, that is volume increasing, number of mole or particles increasing. Here temperature and pressure definitely remaining constant. If it is volume, and the same formula can be also used, V1 N1 is equal to V2 N2. Molar volume of liquid. Bm, that represents the molar volume, is equal to molar mass divided by density of the liquid. Take an example. In the case of pure water, that is molar mass is 18, density 1 gram per centimeter cube. So molar volume is 18 cc. Better example, take mercury. Molar mass 200.59. Its density is 13.6. So what is molar volume? That is 14.75 cc. Numerical problems. As I cited earlier, that some numerical problems are solved here for better understanding the concept. Dry ice block, that is pure CO2 solid, weighing 880 grams. You have to determine how many moles of oxygen atoms present in it. 1 gram mole of dry ice, that is 12 gram carbon, 32 gram oxygen, making 44. Hence 880 divided by 44 gives 20 gram moles. 1 gram mole of dry ice contains 2 gram atom of oxygen. 20 gram mole, 40 gram atom. So 40 moles oxygen atoms are present. Stainless steel, it is an alloy of chromium along with iron and nickel. Percentage of chromium is 10.5% here. Sample weighing 100 gram. You have to determine how many mole of chromium atom. So it is 10.5 gram chromium present because it is 10.5%. Now 1 gram atom of chromium is 52. 10.5 gram atom of chromium, that is this divided by this mole of chromium. So 10.5 gram of chromium is 0.2019 mole of chromium atoms. This is one more good example on bioinorganic chemistry. Healthy person having 15% hemoglobin. Hemoglobin is a metalloprotein of iron. You must be knowing that hemoglobin is part of blood. 10 ml blood, how much iron is present in terms of mole? That is, you are to determine. It is given that molecular weight is 64,458 gram per mole. It is a tetramer unit. So 4 ferrous ions are present in it. When 10 ml blood, that means 1.5 gram hemoglobin is present. 64,458 gram hemoglobin contains 4 moles of ferrous ions. 1.5 gram hemoglobin, that is 4 into 1.5 divided by 64,458. That much mole of ferrous ion. So it contains 9.308387 into 10 to the power minus 5 mole of ferrous ion. Glass of glucose solution, that is 200 ml. It is 25% glucose is present in it. You are to determine how many more molecules of glucose present in, not mole, molecules. Formula C6H12O6 and its formula mass 6 into 12, 12 into 1 plus 6 into 16, making 180 atomic mass. 200 ml, 25% glucose means 50 gram glucose is present in that glass solution. In this solution in glass. 1 mole glucose contain 180 gram. So 180 present in 1 mole. 50 gram present in this much mole. 1 mole glucose is about the number of molecules. So this much mole is this molecules. That is 1.67231 into 10 to the power 23 molecules of glucose. Determine the mass of aluminium in a sample. The compound is Al2O3, which contains 3.011 into 10 to the power 23 atoms of oxygen. The number of mole of oxygen, that is 3.011 into 10 to the power 23 divided by Avogadro number, that is 0.5 mole. In the molecule Al2O3, 3 moles oxygen atoms combine with 2 moles aluminium atom. 3 moles oxygen combine with 2 mole. So 1 mole oxygen combine with 2 by 3 mole aluminium. So 0.5 mole oxygen combine with this much mole of aluminium. Atomic mass, that is given here, 0.3333 mole. The mass of aluminium 27 into 0.3333. Hence, mass of 0.3333 mole aluminium is roughly 9 or 8.9991. Element B combines with C, forming compound B2C3. In this compound, 42 grams of element B containing 4.515 10 to the power 23 atoms. 0.5 mole of this compound weighing 80 grams. What is the atomic mass of element C? As a matter of fact, you are not also knowing the atomic mass of element B, but some data is given where from initially you are to determine the atomic mass of element B, then C. Number of mole of element B, this much atom divided by Avogadro, that means 0.75 mole. So atomic mass of element B, 42 divided by this mole is 56 atomic. Molar mass is easy because 0.5 mole 80, so 1 mole is 160. Hence we can write 2B plus 3C is equal to 160. Putting the value of B, 3C is equal to 48. Hence C is equal to 16 atomic mass unit. Thanks for watching this video. Please subscribe the channel if not done earlier. If you like this video, give a thumbs up. Your valuable comments are very much required to improve the quality of the video. Next video is hybridization and molecular geometry best explained.